So today we chose the problem specifically in which the geometry, this power would be evinced. Okay. So firstly, let's start with the first question. The first question says, let complex numbers alpha and alpha 1 by alpha bar lie on the circle x minus x bar. Okay, one. Yeah, lie on the circle with center x0 comma y0 of radius r, and 1 by alpha bar lies on the circle say with the same center but with radius 2r. If z0 equal to x0 plus iy0, such that 2 times mod z0 equal to r square plus 2, then mod alpha equal to what? So you should find out mod alpha. So generally, if you just go by algebraic formulation, it would take a lot of time, but we'll see today how going by geometric approach will reduce your time. Yeah, we'll choose white color just to be more bright. See, firstly, let's draw the picture here. Sorry, I'm not a good artist, but yeah. Let this be the origin. Let this be z0, and its radius is r. This is circle on which alpha 1 is lying. Alpha is lying. Let me draw another circle on which 1 by alpha bar is lying. Okay. Now you see this distance, okay, from origin to z0, which is mod z0, is given to be root over r square plus 2 by 1 by root 2. Okay. Now you see, let's investigate alpha and alpha bar a bit closer. Suppose alpha, modulus of alpha is r e power I theta. How will alpha bar look like? 1 by alpha bar. This is same as 1 by r into e power minus I theta, because alpha bar is this thing. This is same as 1 by r into e power I theta. See, the catch here is both of them have the same e power I theta form. I mean, the only magnitude is different, but they lie along the same line. So that is the catch. So that means what? These two lie on the same line with respect to origin. Okay. Now what I would do is, I would attach these 2 points. I think the diagram is not so clear. I'll redraw the diagram. So that's the one issue with using this thing is you should really draw it well to make anything out of it. Pen. Okay. So firstly, this is a circle where alpha lies here. This is an even big circle. So you see, let us put this is alpha. This is 1 by alpha bar. Okay, let's not do this. This is what? Z0. So let's just join this. Okay. This one and this one. Now you see, for both the triangles, you know this value, you know mod exactly. So mod alpha is what you should find out. So let's put mod alpha equal to x. Okay. You know, this is x. What is this? What is mod of 1 by alpha bar? Equal to 1 by mod alpha bar, which is same as 1 by mod alpha, which is equal to 1 by x. So if this is x, this is x, this entire thing is 1 by x, correct? This entire thing is 1 by x. Now you should use the fact that this angle is same for both the triangles. How? By using the trigonometric formula. Cos theta equal to mod z square plus, what is this? Z0 minus alpha. This is r, you know, no? From center to alpha, it's r, plus r square minus x square by 2 times mod z into r. This is when you consider this triangle. When you consider this big triangle, what do you get? Okay, 1 minute, I'll write that in the next page. You get the same thing. Cos theta equal to mod z square plus 4r square, because the circle radius is 2r now, minus 1 by x square by 2 into mod z into 2r. Equate them both. You substitute what is mod z, you will get the final answer to be x equal to 1 by root 7. See, we already discussed yesterday itself that this session is meant to teach you techniques, not the computational lengthy calculations. You should be able to do it by now since you've already qualified JEE main. So what have we done here? So essentially, so whenever you see such equations, you see x minus x naught times circle equations, just draw it. The geometric solution is much shorter and much time, you know, saving than the analytic or algebraic expression. So go by this way. So option C is the correct answer. Any doubts? Like how you should identify? I already told you. This had been made possible because these two angles are same, then modulus is same, See, the geometry simplifies it very much. Just that it's easy. Anybody can see that this angle is same. You just have to apply cosine law. But getting this figure is tough. That happens only if you do it geometrical. Analytically, I don't know. You could go wrong in any step. The steps are very less here. So the probability of going wrong is also very less. Next one, this is an interesting question. It says z equal to x plus y is a complex number. Okay. So z into z bar cube plus z bar into z cube equal to 350. Now we'll do one thing. We'll take the common one, that is z bar square plus z square equal to 350. Now what is this? This is mod z square. Z bar is mod z square. We all know that. Now we see we'll simplify. What is z bar square? It is x minus iy whole square. I don't know why I'm doing it's computational, but yeah, x square minus y square plus some imaginary part, z square equal to x plus iy whole square, which is also x square minus y square plus I times something. Let's not care because they get cancelled, right? Minus. Yeah, it's minus here plus here. Yeah. So what you get here is 2 times x square minus y square equal to 350. Okay. Now what do? Mod z square is same. If z equal to x plus y, mod z square is x square plus y square. X square plus y square into x square minus y square equal to 350 by 2, which is same as 175. Let's factorize 175 because left side given its integer. You cannot have 175 by root 2 into root 2. That is also a factorization, but they said x and y are integers. So you can only factorize them as product of integers. Let's see. Obviously, it's divisible by 5. 5 3s are 15, 5 35. So 5 7s. Okay. So this is same as 25 into 7. Okay. So 25 is something like, see, this is bigger than this. So 25 must be x square plus y square. X square minus y square must be 7. Let's solve it. X square plus y square equal to 25. X square minus y square equal to 7. When you add them, you get what? 2x square equal to 32 or x square equal to 16. So x equal to plus or minus 4. If x equal to plus or minus 4, y will be plus or minus 3. Yep, yeah, 16 minus 1. So now let's plot this. Okay, x equal to plus or minus 4, y equal to plus or minus 3. So 4 comma 3, 4 comma minus 3, minus 4 comma minus 3, minus 4 comma 3. Okay, this is a rectangle. All the vertices are solution of that equation. So what is this length? It's 8. What is this length? It's 6. So what is the area of a rectangle? 8 into 6, which is 48. What is the answer? It is this. Please do ask me if you have any doubts. Do not sit idle because you see, how would I know if you're understanding or not? Yeah, this is one of the very interesting questions which was asked in JEE in the last few years. So you're given that sz plus tz bar plus r equal to 0. So we are used to seeing straight line equations in real variables, but for a change, they have given complex variables. In fact, if you study what's known as complex analysis, you learn that all the geometric figures in 2D also can be described in terms of complex numbers. This is one such example taken directly from complex analysis. So how do we solve it? So why should we care about all that? I'll tell you. This is a given equation where S, T, R are non-zero. Note this down. They are not zero. This is very important. They're all non-zero complex numbers. So you see, this is 0, right? This is a real number. So whenever you have some complex number equating to some real number, it's better to check the conjugate. And please note down these techniques as I tell you in some rough book or somewhere, because when you get into JEE, the last minute preparation should be remembering all these techniques. Whenever you have a complex number equated to some real number, immediately take the conjugate on both sides. That will give you some additional information about the complex number. That's what I'm doing here. So now you see, okay. Now, isn't it easy to solve for the Z? How do you think I should solve for Z? Obviously, this is X, this is Y. Think of that the same way. So now, multiplying this both sides with S bar, what do you get? S bar S into Z plus S bar T Z bar plus S bar R equal to 0. I'm just solving it like AX plus BY equal to C, CX plus DY equal to E. How do you solve it? That's the same thing I'm doing. But this is the first time you're seeing such questions. I'm doing all the calculations. S bar into, okay. Now multiply the second equation with T. T S bar Z bar plus T into T bar Z plus T R bar equal to 0. Now you see these two are same. When you subtract, these two will get cancelled. So what do you get? Mod x s square z minus mod t square z plus s bar z minus tr s bar r minus tr bar equal to 0, which is same as saying mod s square minus mod t square to z equal to tr bar minus s bar r. So z should be equal to tr bar minus s bar r divided by mod s square minus mod t square. So any z on that line should satisfy this. So what do you get from that? That means what? Depending on s and t, the number of z satisfying this would vary. So, so you see, s has exactly one element. See, the denominator must, see, if the denominator is 0, numerator could be anything. Always z would be infinity. There are infinitely many numbers. 10 power 7 is also infinity. 10 power 9 is also infinity. So if this is 0, of any numerator could be anything. So there are multiple real numbers for which z will stand for, multiple complex numbers for which z could stand. But if you fix s bar is not equal to t bar, that means s bar square minus t bar square not is 0. That means s is fixed and t is fixed. Obviously, you can only have one element, correct? If you fix t, if you also fix r, so option A is correct. Firstly, by the same logic, if mod s equal to mod t, any s and t you could choose and still it could be infinity only. So obviously option B is also the correct answer. Oh, then L has infinitely many elements. Okay. Wait. I think we're going wrong somewhere. No. This is not correct. We have gone wrong. If mod s equal to mod t, z should be infinity. Okay. 1 minute. Let me go geometrically. So z says r bar t minus s bar r by mod s square minus mod t. First one is definitely correct. Yeah, that is there. Because mod s is not equal to mod t, then exactly has one element. That is true. Suppose if mod is equal to mod t, then z should be infinity. If mod is equal to mod t, if you take the modulus there. Oh, okay. Sorry. If mod is equal to mod t, then obviously r also should be fixed, right? So it could also be 0. There need not be any element at all. I'm saying it's not that you should have a unique element. There could be 0 elements or there could be infinitely elements. So L has infinitely elements or 0 elements. You cannot say there is at least one z. That is wrong. So this could be correct because the statement is incomplete. This could be correct. So 1 minute. I think option B is wrong because you see it's incomplete. L has infinitely many elements or 0 elements, then it would be correct, but they did not give 0 elements. We excluded that case here. Now obviously, so z is a straight line, right? I mean z equal to, as you vary that, if s and t are fixed, so z number of z which lie from this is 1 comma minus 1. See, again I'm using the circle and the radius is 5. So how many points will a straight line intersect a circle maximum in? It can intersect in 1 if it's a tangent, but at the max it can intersect only in 2. As you vary r, it would be a straight line, right? So obviously option C is also the answer. So if L has more than one element, if L has more than one element, that means if mod s equal to mod t, see that's what I told, right? It has infinitely many elements or 0 elements. That's what they're capturing element. If L has more than one element means what? L could also be 0 element. There could also be no elements. But they're saying remove that case. We are saying suppose if L has more than one element, it has infinitely many elements. That was exactly option B, right? So in case of mod s equal to mod t, L could have be 0 elements or infinitely many elements. But they're saying L has more than one element. That means the case that it has 0 elements is excluded. So obviously L should have infinitely many elements. I know this question is a bit complicated. It's too tough for students who have not seen it before, but you cannot help it, right? It's JEE Advanced, so they come up with tough questions. But anyway, if you think geometrically, what did we do? We just solved for Z, then investigated. Based on the expression, we have just seen how well Z behaves. Okay. Okay. Now, yeah, this is another question where geometry plays a very important role. So if Z1 equal to A plus IB, Z2 equal to C plus ID, and Z. See, now you see, I'll draw a circle. This is the center. Suppose this is Z1 and this is also Z2. The circle radius be 1. That's what they say, no? The distance is 1. This is 0, 0. They said mod Z1 is 1, mod Z2 is 1. Okay, fine. If real part of Z1, Z2 bar equal to 0. That let's see. So Z1 equal to say e power I theta 1. Say Z2 equal to e power I theta 2. I mean, if this is the angle theta 1, this is the angle theta 2, let's say. What is Z1 into Z2 bar? E power I theta 1 minus theta 2. Now, what is its real part? The real part of Z1, Z2 bar is 0 means what? Cos of theta 1 minus theta 2 is 0. Correct. But when is cos of something theta? When theta 1 minus theta 2 equal to pi by 2, we are taking the principal values because only 0 to 2 pi is allowed. So this angle is 90 degrees. Theta 1 minus theta 2 is what? This is entirely theta 2. This is theta 1. So theta 2 minus theta 1 means what? That means the angle between them. This angle is pi by 2. Okay, so how does this even help us? That is pi by 2 means what? So theta 2 equal to theta 1 plus pi by 2. So Z2 equal to e power I theta 1 into e power I pi by 2. But this is Z1. What is e power I pi by 2? Cos pi by 2 plus I sin pi by 2. This is I. So now equate them. Z2 equal to Z1 into I. So Z2 equal to Z1 into I. Z2 equal to C plus ID equal to A plus IB into I, which is equal to minus B plus I into A. So C equal to minus B, A equal to D. Okay. So this is there. So what is Z2? Okay, Z2 will write in terms of Z1. Okay, Z2 equal to C plus ID. No. What is C minus B? What is D? IA. Now you see, yeah, Z1 into, okay, that's it. So Z2 equal to C plus, okay. Mod Z1 equal to 1, mod Z2 equal to 1. Omega 1 equal to A plus IC, W1. W1 equal to A plus IC. W2 equal to what? B plus ID. But what is B? B is minus C. What is D? D is A. So W2 is also equal to I times W1. Okay, now you see A square plus B square equal to 1 because mod Z1 equal to 1. But A is also equal to D. D square plus B is also equal to C. Say C square equal to 1. Okay. C square plus C square equal to 1. So add them both. You get what? A square plus D square plus B square plus C square equal to 2. But A is D, same as D. So 2A square plus B is C plus 2C square equal to 2. So it says what? A square plus C square equal to 1. That means what? Mod W1 equal to 1. So if mod W1 equal to 1, mod W2 is also equal to 1 because mod I into mod W1, mod I is 1. Now again you see W2 equal to I times W1. That means what? W2 equal to e power I pi by 2 into W1. So W1 rotated by 90 degrees will give you W2, which is same as saying real part of W1 into W2 bar is 0. We have done it, no? 90 degrees. So option A, option B, option C, all the three are correct. See, we are just choosing the rotation of a complex number, the geometry of a complex number. So multiplying a complex number by e power I theta would just increase its phase by theta. Multiplying a number by a real number would increase its amplitude. That's the only thing we are using in all the problems. Okay. Now let's come to a fifth question. Read the following passage and answer the questions that follow. Let A, B, C be three sets of complex numbers as defined below. A equal to, okay, fine. I think, do we have duplicate set? Okay. Let's first draw this. A is set of all Z for which imaginary part of Z is greater than 1. That means what? Set of all Z lying here. Correct? This is 1. Okay. B z minus 2 minus I is 3. Okay, that means 2 plus I, 2 plus 1, 2 comma 1. So x is 2, y is 1. So it lies somewhere here, right? 2 comma 1. And a circle with radius 3. This is 2. Okay, so this has a radius 3. 5 comma 1. 5 comma 1 is the other side. What is 3 units minus 1 comma 1 is the left hand side, no? Because the radius is 3, right? So this is the circle. And real part of 1 minus I into z is equal to root 2. So you get if z equal to x plus iy, what do you get? 1 minus I into x plus iy, this real part must be root 2. So what is the real part of that? X plus y equal to root 2. If x and y are the real and imaginary parts of z, sum of their real and imaginary parts must be root 2. So obviously, see y equal to x minus x plus root 2, right? So yeah, y equal to, is this correct? 1 minus I, okay. So y equal to minus x plus root 2. Okay. It lies somewhere here, right? Where it intersects, I mean. Okay, so will y 5 comma 1 lie towards the left or right? Okay, equal root 2 or else, oh, this is root 2. Okay, so the slope of the line is what? Y equal to mx plus c. Slope of the line is minus 1 and it's at root 2. Okay, it starts somewhere here. Oh, okay, so this intersects the circle. Okay, sorry, this is the equation, no? The y-intercept is root is greater than 1. The slope must be 135 because it's minus 1. The slope is minus 1. So it only intersects the circle in here. So this single point is all that we are interested in. So A intersection, B intersection is just this single point. So set of all points here. Then first of all, everything above 1. Then everything on the circle and above 1. So this below part will go, it will vanish because only above part intersection. So intersection of A and B will be this entire circle. Sorry. And this intersection of this the semicircle with a straight line is Z, that is C. Intersection of the semicircle is the intersection with that intersection with C, this single point. 1 minute, I'll just talk. Okay, so this is the point. Sorry, this is a point y equal to y plus x equal to root 2. Okay, so the first answer is number of points is just 1. Again, geometry. This diagram is going to help us like hell. Okay, this is the sixth one. Okay, this is the other question. 1 minute, sorry. Okay, now same thing. Z be any point, I mean the single point which we're discussing, and omega be any point satisfying. Okay, we'll redraw the diagram. How was the diagram? It was like this. Okay, this was 5 comma 1. This was minus 3 comma 1 or minus 2 comma 1. 1 minus 3 is minus 2, no? Let me check. Minus 1. Okay, 2 comma 1 and minus 1. Okay, this is the center. Minus 1 comma 1. This is our Z. Okay, now what are they asking? Omega also lies in the same circle. See, this is the equation of this circle is what? This part. Mod Z minus 2 minus I equal to root 3. So only the circumference would come. But now we are considering mod Z minus 2 minus I is less than root 3. So strictly inside the circle. Okay, somewhere here. Okay, somewhere here. Now you see, this lies between what? Mod Z minus mod omega plus 3. So mod Z minus mod omega is always less than mod of Z minus omega. Correct. By triangle inequality, we know this inequality. But mod z minus omega is what? See, omega could lie anywhere here. We do not know where it lies exactly. So, yeah, in fact, it could lie even in the below circle also. 1 minute. Let's complete this. This is the equation of circle. So what if omega lies here? It could also lie here, right? Because there is no restriction that it should lie only on the upper circle like we had. No imaginary part is greater than 1. No, the only thing it says is, this thing is blocking my speaking. The only thing it says is mod of omega minus 2 minus I is less than 3. So there is a circle with radius 3. The first half coincides with this, our locus, but it could also lie here. So the worst case is the distance is maximized when they are diametrically opposite. That means what? The distance between them is 2 times the radius. Okay, so this happens only when mod z, see, so mod z minus omega is less than or equal to 6. It cannot go beyond that. No, the distance, the largest distance between 2 points lying in a circle is when they are diametrically opposite. That will be 2 times the radius. So obviously, so mod z minus mod omega is lies between minus 6 to plus 6. When you add 3, you get what? 9 less than mod z minus mod omega plus 3 is less than minus 3. This is what you need. See, even JEE Advanced emphasizes on geometry much more than JEE Main does. That's the main difference from JEE Main to JEE Advanced. JEE Main you can get away with just doing algebraic expressions, but JEE Advanced you should think geometrically. Otherwise, the entire 1 hour will go for solving a single problem itself. Okay, so minus 3, minus 6, and okay, 1 minute. What is this? Okay, 9 and minus 3. Okay, option D. Sorry. Yeah. So next question is this. Okay. Interesting question. This is high school geometry. Let me say why. Again, the same thing. You see, if you observe the points they have asked, they are the endpoints of the diameter. Like we have said, right? The center is 2, 1. The diametrically opposite points are 5, 1 and minus 1, 1. Obviously, these are the points they are asking, and you know the z lies somewhere here. We do not know. We don't even have to calculate that. So they're asking the distance square from this to this. Sorry. Eraser. Okay, I'll just use the pointer again. You see, join them. This is a straight line. Now also, why am I doing this? What's wrong with me today? I have to just join these 2 points. Okay, 1 minute. I'll choose eraser. Eraser. Okay. Okay. Now you see there's an important high school theorem which will come handy here. This is a semicircle. This is a diameter. This is some arbitrary point. The angle in a semicircle is always 90 degrees. Remember the theorem, angle in a semicircle is always 90 degrees. So this is an angle in a semicircle, it's 90 degrees. So this distance, what they are asking, hypothesis, this square plus this square equal to this square, Pythagoras theorem. So mod z minus z plus 1 minus I whole square, I mean base square plus other side square is hypotenuse square, plus mod of z minus 5 minus I whole square. So this square plus this square equal to hypotenuse square. But what is the hypotenuse? 6 square, that is 36. The distance is 5, 1 minus 1, 1 is 6. The answer is 36. So obviously the answer is 35 to 39. In fact, it's the fixed number, but just to confuse you, they give that answer. Understood how geometry is helping you? You have used Pythagoras theorem, you have used the angle in a semicircle is 90 degrees, you have used all sort of things. This is how you try to solve the problem. Just by geometry. Okay. Now, this is another problem on geometry. In fact, all the passage problems which we could find were on geometry only. We could not help it. So now you see, S1 is Set of all circles. Okay, S1 and S3 will plot first. This looks nasty. Okay. 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 So we'll draw the standard X and Y axis. We'll first draw the locus of S1, which is mod Z equal to 4. So this is a circle of radius 4. Fine. This is circle of radius 4. This is S1. And the second one says real part of Z is greater than 0. All the points which are lying to the left, this left of the circle, have real part of Z less than 0. So should only consider this part, this entire part for S1 and S3. Now S2 is, okay, let's simplify how S2 stands for. So Z minus 1 minus root 3I by 1 minus root 3I is greater than 0, the imaginary part. So this says what? Z by 1 minus root 3I is greater than 1, correct? Okay. So imaginary part, okay. So imaginary part of this is greater than 1. 1 minute. Sorry. I think I'm going wrong somewhere. Let me just clarify it. This is same as imaginary part of Z by 1 minus root 3I minus 1. This is a real number. So this is same as imaginary part of Z by 1 minus root 3I. This should be greater than 0. So let's simplify Z by 1 minus root 3I. So Z by 1 by 2 minus root 3 by 2 into I, this thing into 2. So again, we'll use geometry, that is same as Z by 2 into, what is this? E power I, 1 by 2 and minus pi by 2, cos 60, cos of minus 60, sine of minus 60. Okay. E power I minus pi by 3. Okay. So Z by 2 into e power pi by 3. So imaginary part of this should be greater than 0. So obviously this is just, you can ignore it. So imaginary part of, suppose Z is equal to R e power I theta into e power I pi by 3 is greater than 0. So sine of, what is its imaginary part? Sine of theta plus 60 degrees is positive. So theta lies, they're saying this is the angle. So theta should be from, theta can be from 0 to minus 60, right? Only then. See, theta plus 60 is positive, means what? Theta could be 0, but theta could be minus 60 also. If it's beyond 60, obviously say minus 61, it is negative. So you can only take it till minus 60 degrees below. So what is the area here? What is the net area? Okay, we'll erase the unnecessary stuff. Okay. So this is the only area you're looking for. Did everybody understand? Because we're just simplifying this. I'll just go through because you might get confused. So imaginary part of this is greater than 0 is, I'm just writing minus 1 plus root 3 as minus of 1 minus root 3. Then this will get cancelled. You get imaginary part of Z by 1 minus root 3I minus 1. But this is same as, this is a real number. A complex number's imaginary part doesn't get changed when you add or subtract a real number. So this imaginary part of this is same as imaginary part of Z by 1 minus root 3. This should also be positive. Now I'm writing 1 minus root 3I by 2 into y, because I should write it in terms of a complex number, polar form. Z by 2 into e power minus I pi by 3. This will become imaginary part of Z by 2 into e power I pi by 3 is greater than 0. Again, just positivity doesn't change when you multiply and divide by positive numbers, so we can get rid of 2 also. So imaginary part of Z e power I pi by 3 is greater than 0. If you write Z to be R e power I theta, that is same as R e power I theta. I'll write it here. So that is same as imaginary part of R e power I. Okay. Eraser. R e power I theta plus pi by 3 is greater than 0. but imaginary part of that is r sine theta plus 60 degrees, right? If this is positive, means what? Theta could be, theta runs from 0 to minus 60. Obviously for positive values of this thing this is, but for negative values of theta up to negative value of minus 60 degrees, this will still be positive. So this is the area you want to know. Now z minus, okay, 1 comma minus 3. So what is the equation of this line? Y x y, okay, wait, this is what x r cos theta. So this is 1 by 2 comma minus root 3 by 2. So y equal to root 3x minus root 3x. So 1 comma minus 3, right? 1 comma minus 3. So this radius is 4. So 1 comma minus 3. If you put y equal to 1, you get 1 minus root 3. So it is below this line. The shortest distance. Minimum is when you write the perpendicular distance. You know the equation of the line, you know the point, you know the shortest distance from a point to a line. I did not tell you all that. So this is, the answer is same as 3 minus root 3 by 2. See, the logic is just deriving that this is the area. Then you know 1 comma minus 3 doesn't lie here, because when you put y equal to 1, you get only minus root 3. Root 3 is greater than minus root 3, so it should be below. Then it's just a perpendicular distance. That's it. Now area of S. See, area of the sector, that is a sector with 150 degrees. This is 90, this is, so this is 150 degrees. The radius is 4. So we know the formula, right? R square theta by 2. So what is R? 4 square by 2 into, what is 150? 150 is 5 pi by 6, no? 1 minute. 150 is 60 into 60 by 2 into 3. So 3 by 2 into 5 by 3. Huh? Wait. Okay, sorry. 16 to 3 is 18. Okay, 60 by, okay, 5, no? Because 60 by 2 is 30, 5 by 3. Okay, so it's 5 by 2 into 5 by 3. So 5 pi by 6 into. So 16 by 2 is 8 into 5 pi by 6. 2 4s are 2 3s are. So this is 20 pi by 3. The answer is 20 pi by 3. Area of S, ask for it later. You see many problems. That's why I suggest you just go to the geometry of complex numbers again and again. Okay. Just go through the complex numbers again and again. So yeah, 1 minute. Okay. Okay. Fine. Thank you. The key got pressed unnecessarily. Okay. Match the columns. This is also geometry. Let's do it. See, you don't have to solve it when you're given options. Okay, just have to verify which of the right side is satisfying the left side. Okay, x minus ix, x plus ix. See, suppose if z minus iz equal to mod of z plus iz, what can you say? I'll solve one problem. Others are much similar. Okay, so one. See, when two numbers are equal in magnitude, what can you say about them? They are e power I theta times each other, right? Okay. Let's just substitute x equal to x plus iy. Mod of x plus iy minus I times x square plus y square under root equal to x plus iy plus I times under root x square plus y square. Square on both sides, you get what? Mod z square, that is x plus iy. Okay, let's just do it. X plus I times y minus under root x square plus y square modulus is same as modulus of x plus I times y plus under root x square plus y square. Squaring on both sides, what do you get? X square plus this. Oh my god. I think this is becoming lengthy, right? Let's look for the shorter version. Let's see. If you divide by mod z on both sides, what do you get? Okay, if you divide by mod z, because mod z is generally not zero. So what do you get? Mod of z by mod z minus I equal to mod of z by mod z plus I. So z by mod z, the modulus is 1. So that number lies on the circle, correct? Of with unit radius. The points on the circle whose distance from minus I, that is minus 1 and plus 1 is the same. What are those? Which are equidistant, which lie in the perpendicular bisector. So obviously this is on the x-axis. That means imaginary part must be 0. So okay, mod z is not equal to 0. So is that equal to 1? Imaginary part is less than or equal to 1. Yeah, so it's contained in, okay, it's contained in or equal to. See, for equal to, obviously this imaginary part of z is less than equal to 0 would suffice. Contained in what? Suppose imaginary part, suppose if imaginary part is less than 1 also, it's contained, right? I mean, the set of all the distances from those 2 points may not be same, but it is contained. So the first option would be q comma r. We'll do the second one also similarly. Set of all points z satisfying x z mod z plus 4 plus mod z minus 4 equal to 0. Huh? Hook into positive number z is equal to plus or minus 4. No points, right? Okay, but we know this, no, ellipse, it's also put in the intermediate syllabus for CBSE. The sum of the locus of all the points for which the sum of distances from two different points is same. I think it should not be 0, it should be something else, maybe some eccentricity or something. Obviously it is an ellipse. Rest all cannot satisfy, because it's known that the locus of all points for which the sum of distance from two fixed points is fixed is ellipse. So obviously this should be P. Can we eliminate any options? Q comma R P. Oh, I think option B is the answer, because Q comma R and P is only coinciding for that. But anyway, let's solve other questions. Mod omega equal to 2, then the set of points z equal to omega minus 1 by omega. Okay. Oh, this is for C. Okay. If mod omega equal to 2 means what? Omega equal to 2 e power my I theta. Then omega minus 1 by omega. 2 times e power I theta minus 1 by 2 into e power minus I theta. What is this? 2 cos theta minus 1 by 2 cos theta plus I into 2 sin theta plus 1 by 2 sin theta, because it will be minus sin theta. So what is this, man? 3 by 2 cos theta plus I into 5 by 2 sin theta. Let's see. Set of all numbers which sat with this locus. Okay. Okay. Obviously, the modulus is less than it is contained in the ellipse. That is true. Suppose what if imaginary part is okay? Sorry, PST. Real part of z is less than 2. Suppose if cos theta 3 by 2 cos theta is less than 2. So 3 cos theta is less than 4 by 3. That is trivial, man. Obviously. So this is 3 by 2 cos theta. Obviously, 3 by 2 cos theta. So that means what? 3 cos theta is less than 4. Cos theta is less than 4 by 3. This is a universally true. Cos theta is always less than 1. So obviously P would be there, S would be there. Set of all points satisfying mod z less than 3. Mod z less than 3 means what? What is the modulus of this thing? Should be less than 9 and you square it. 9 by 4 cos square theta plus 25 by 4 sine square theta. 36, 34 by 4. By Cauchy's inequality, this is less than or equal to, okay. This should be less than 9. Okay, that means this should be less than 36. Obviously, right? Because cos square theta is less than 1, sin square theta is also less than 1. So the maximum this can take is 9, the maximum this can take is 25. When you add them both, you get 34. It's less than 36. So yeah, PST. So PST is also an option. D1 also will solve omega plus 1 by omega. Okay, I think this should be equal. So d omega z equal to, now again it's e power I theta mod is 1 plus e power minus I theta. This is simple. For I theta minus I theta z plus 1 by z omega equal to 1. So this is same as 2 cos theta. Set of all points which lie inside the circle. Right. So whereas t, obviously imaginary part of that, like all the real numbers would satisfy, imaginary part less than 1, obvious. This all would satisfy. But this is not true because the figure goes out of the ellipse, so it's not contained in totally. So QRST. So fortunately, finally, we have solved all the problems. 10th problem is also done. What is the time? I don't know what's the time now. See, the only thing we have emphasized here is, even when we are searching for some questions, nice tough questions, the only thing we could get were the tough questions were based on geometry of complex numbers. So please revisit the geometry of complex number. See, for instance, we solved a question here by dividing by mod z on both sides, right? You don't have to take x equal to I. So what did we do? We just did z by mod z minus I equal to mod of z by mod z plus I. So set of all unit modulus numbers, I mean u minus I equal to u plus I. So set of all numbers, unit modulus numbers u, which are equidistant from I comma minus I. This is I, this is minus I. All the points on real axis also would be there. Okay. And this line is also contained in set of all numbers for which imaginary part is less than 1, because imaginary part is 0 for these numbers. Obviously it is less than, it's also contained. So q comma r. But s and t do not satisfy because real part of z less than t is the only thing they have told. But that's not true, because that also includes numbers beyond 1. That is not true for numbers beyond 1. Similarly, mod z greater than 3. It includes a number beyond 1. So only q and r are the correct options. So this is the way. Always think if you should divide, it will give you unit modulus. It's a circle, you should come to mind. If you just write no, it doesn't make a difference. Mod z, you divide or keep x plus iy, that thing stays forever and complicates your life and it takes up a lot of your time. So please think geometrically whenever complex numbers come in the JEE Advanced exam. That's what we have done here also. Here also we have done the same thing, diametrically opposite and stuff. Because I've seen some students when it comes this way, right? They try to find the maxima, they write in terms of x and y, differentiate. Imagine how much time it takes. What did you do? We just thought, okay, diametrically opposite points are the maximum distance, and obviously the radius is 6, so minus 6 to plus 6. That's all we have done, right? Saved you from the labor quite much. So that is it. If you have any other doubts, here also we have used geometry. People would generally say real part of z1, z2 bar means x by a plus ib into c plus id. No, don't do that. Just use geometry. E power I theta times and all these things. Is it clear, everybody? If you have any doubts, please ask me now itself. Even in the first question also we have just used geometry. In fact, there is no question where we have used x plus iy or c plus id. Convert into r e power theta and that's it. That is solving the problem. Please ask me any doubts if you have any. Everybody, please ask me. I'm open to doubts now. No doubts? No doubts, anybody? Okay, if none of you have any doubts in any question, then maybe we should stop the class now. Okay,